At Jodan Shisifen on the morning of May Arshitsi Echen Jobai Sishir, Flight Lieutenant Arthur Clowes pushed his Supermarine Spitfire into a vertical dive over Dunkirk. 4 Messerschmitt Bf-109 were climbing toward him. Standard fighter doctrine. Dive through the formation, break their attack pattern, maintain speed advantage. Clowes pitched the nose down hard. -3 Jan forces. The horizon disappeared above him. The Merlin engine coughed once, then died. Total power loss at 7 less per hour in a vertical dive with 4 German fighters bodying yards behind him. The Spitfire became a Lieutenant glider falling toward the English Channel. Clowes had 3 seconds to decide whether to bail out or try to restart the engine, while enemy pilots lined up deflection shots on a target that could not maneuver or defend itself. Clowes pulled the nose level. The airspeed indicator showed 7 less per hour. Altitude Jochen Babe feet and dropping. He pushed the mixture control to full rich, toggled the fuel booster pump. The engine remained silent. Wind screamed through the dive brakes. The Bf-109 were closing, loading in yards. Clowes recycled the ignition. The Merlin coughed, missed, caught. The propeller windmilled into compression. 1 cylinder fired, then another. The engine roared back to full power. Clowes slammed the throttle forward and pulled into a climbing turn. The lead Bf-109 overshot by 18 yards. Clowes reversed and fired a 2-second burst. The Messerschmitt exploded. Clowes escaped. 19 other RAF pilots died that day when their engines failed during combat maneuvers over Dunkirk. Their engines did not restart. Some bailed out and were captured. Some drowned. Some rode their aircraft into the water at 7 less per hour because they were too low for parachutes to deploy. Between May RSHOTH and June CTs, Fighter Command lost Yaojizi aircraft during the Dunkirk evacuation. Bosch-T pilots killed. Many losses were from engine failures during -G maneuvers. The Messerschmitts did not have this problem. They shot down gliding Spitfires and Hurricanes. The Rolls-Royce Merlin engine was a masterpiece. Liquid-cooled VFR, Arshitsi liters displacement. Etening Sensuschauscher horsepower at takeoff power. Supercharged for high altitude performance. The engine that made the Spitfire and Hurricane the fastest fighters in the European theater. But the Merlin had one fatal flaw that was killing RAF pilots every single day. The SU carburetor used a float chamber system. Gravity kept fuel in the bottom of the chamber where the jet drew it into the intake manifold. In normal flight, the system worked perfectly. In -G maneuvers, physics reversed. When a pilot pushed the nose down hard, fuel surged upward to the top of the float chamber, away from the jet. The engine starved for mouth econs. If the -G continued, the float dropped to the chamber floor. The needle valve opened completely. Fuel flooded the carburetor. The supercharger drowned in an over-rich mixture. The engine cut out entirely. German Bf-109 used Daimler-Benz DB Liutingyal engines. Fuel injection. Direct delivery to cylinders under pressure. No float chamber. No gravity dependence. -G maneuvers caused 0 power loss. The tactical advantage was absolute. When a Bf-109 dove away from a pursuing Spitfire, the German pilot could push -G instantly. The Messerschmitt's engine maintained full power. The Spitfire's engine died. The pursuer became the target. The hunter became the hunted. RAF pilots called it the Messerschmitt's dive Janaway advantage. Between September Jobai Senshajo and May Jobai Sishir, that advantage killed Sishir British fighter pilots in recorded incidents. The actual number was higher. Many pilots disappeared over the channel. No witnesses, no combat reports. Just empty chairs in the mess hall. Beatrice Shilling learned about the carburetor problem on November sen RD. Iten Jobai Senchajo. She was censure years old, Principal Technical Officer for Carburetor Research and Development at the Royal Aircraft Establishment in Farnborough. One of 2 women in her mechanical engineering class at the University of Manchester in Iten Jobai Senchar. Master of Science degree in Iten Jobai Senchasen, hired by the Ray in Iten Jobai Senchar after the Air Ministry decided that women with engineering degrees might actually be useful. Shilling had spent 3 years studying carburetor behavior under every possible flight condition. She knew the SU carburetor's limitations better than the engineers who designed it. Shilling's path to the Ray had been unconventional. Born in Waterlooville, Hampshire on March Bathi Chen Jobadin Jo, daughter of a butcher. At age 6, she bought a motorcycle with money saved from odd jobs, a 2-Jan stroke engine. She taught herself to disassemble it. Every component, crankshaft, piston rings, carburetor. She rebuilt it in her bedroom. Her mother was horrified. Her father was quietly impressed. By age 6, Shilling was modifying engines for better performance. She installed a supercharger on a Norton M. Sanshir in Iten Jobai Senchasen. Hand then fabricated from salvaged aircraft parts. The bike produced 60 horsepower instead of Senchar. She took it to Brooklyn Circuit on August RCTH. Iten Jobai Senchasu lapped at Ibailingyo Yungli less per hour. Second woman ever to exceed Ibailingli Meixiaoshi at Brooklands. She received the British Motorcycle Racing Club Gold Star, one of only 3 women who ever earned it. The engineering establishment did not welcome women. When Shilling applied to the Ray in Iten Jobai Senchar, the chief engineer refused to interview her. Women were not permitted in the engine testing buildings. Fire regulations. Then someone pointed out that fire regulations said nothing about gender. They said nothing about women because no one had imagined women would want to work in engine development. Shilling was hired, assigned to technical publications, writing maintenance manuals. She spent 8 months documenting procedures written by male engineers. Then transferred to carburetor research when the department realized she understood fuel delivery systems better than most of their senior staff. The official solution came from Rolls-Jan Royce. Redesigned the entire carburetor system. Replaced the float chamber with a pressure carburetor. Fuel delivered under constant pressure, regardless of G-Jan forces. Engineering time required, Shibami-onths minimum. Tooling and production setup, Lil-mi-onths, total time, until operational deployment, Arsha-si-mi-onths. The Battle of Britain was scheduled to begin in approximately Bom-m-onths. Shilling understood the mathematics. Arsha-si-mi-onths of engineering elegance versus Bom-m-onths, until the Luftwaffe attempted to destroy fighter command. The equation did not balance. She worked the problem in her home workshop during November Iten Jobai Senchajo. The carburetor needed fuel. Not too much, not too little. Exactly enough for maximum power at combat settings. The float chamber could flood because fuel flow was unrestricted. Restrict the flow, prevent flooding, maintain power. The solution was a flow restrictor. A brass washer. Precisely calculated hole diameter. Install it in line between the fuel pump and carburetor. Limit maximum flow to slightly less than full power demand. Physics would handle the rest. During positive G flight, fuel flowed normally. During negative G, the restrictor prevented surge flooding. The float chamber could not overwhelm the jet because fuel delivery was mechanically limited. Shilling calculated the hole diameter using fuel flow rates at maximum combat power. The Merlin consumed Joshisi imperial gallons per hour at 10 RPM and plus Fouchard boost pressure. Convert to volume per second. Calculate pipe diameter. Factor in fuel viscosity. Determine orifice size that would pass Joshijodar % of maximum flow. The number was Lingdarn sen inches, 0.03 of an inch. The thickness of a human hair was Lingdarn sen inches. The restrictor hole was 10 times that. Machining tolerance had to be plus or minus Wu inches, half a thousandth. Any larger and the restrictor would not prevent flooding. Any smaller and the engine would lose power during sustained combat. She machined the first prototype on her home lathe. Brass disc, 1-inch diameter. 0.001 hole drilled through the center weight. 10 grams. Cost of materials, approximately 6 pence. She brought it to the Ray workshop on November Shabathi Ichenjobai Senshijo. The chief engineering officer examined it for 6 seconds, then told her it would never work. The hole was too small. The restrictor would choke the engine. Fuel pressure would drop. Power loss would be catastrophic. Shilling requested permission to test it anyway. Permission denied. The Ray had already approved the Rolls-Jan-Royce pressure carburetor program. Unofficial modifications to operational aircraft engines were not permitted. Shilling installed it anyway. She requisitioned a Merlin engine from the test facility, mounted it on a tilting cradle in the workshop. The cradle could rotate the engine to any angle, including full inverted. She ran the engine for 60 hours over 6 days. Every power setting from idle to maximum emergency boost. Every angle from level flight to negative 3G simulation. The restrictor worked. Power loss during negative G maneuvers dropped from 1.5 seconds to 1.5 seconds. Still noticeable. Not fatal. Pilots could execute diving attacks without engine failure. The Messerschmitt's dive Janaway advantage was neutralized. The testing revealed unexpected benefits. At full combat power with the restrictor installed, the engine actually ran smoother than stock configuration. The restricted fuel flow created more consistent pressure in the carburetor float chamber. Fuel delivery became more predictable. During the 60-hour test, Shilling documented every temperature reading, every pressure measurement, every fuel flow variance. The data showed the restrictor caused zero mechanical stress on engine components. No increased wear on bearings. No unusual heating patterns. The modification was completely transparent to engine operation except during negative G conditions. That was when it mattered most. Shilling wrote a 23-page technical report. Detailed calculations. Test methodology. Results analysis. She included photographs of the restrictor. Diagrams showing fuel flow patterns with and without the modification. Graphs comparing engine performance across different G loadings. The report concluded that the restrictor was a viable interim solution until pressure carburetors became available. Implementation cost was negligible. Installation time was minimal. Risk was essentially zero. The report recommended immediate deployment to operational squadrons. The test data went to Air Chief Marshal Hugh Dowding, commander of RAF Fighter Command. Dowding read the report. Watched a demonstration. Made his decision in 4 minutes. Install Shilling's restrictor in every Merlin. Powered fighter and fighter command. Immediately, Rolls-Royce Engineering Division objected. The modification had not undergone proper qualification testing. Service life analysis was incomplete. Failure mode assessment was not documented. Installation without engineering approval would void the engine warranty. Dowding's response was direct. German fighters were shooting down British pilots because British engines failed during combat maneuvers. A voided warranty would not matter if there were no pilots left to fly the aircraft. Install the restrictors now, analyze the paperwork later. The first operational test flight occurred on the 7th of January, 1941, at RAF Duxford. Squadron leader Douglas Bader volunteered his personal Spitfire MiG to second. Bader had lost both legs in a pre-war flying accident. Artificial limbs. Most pilots would have been grounded. Bader fought his way back to operational status through sheer determination. He was also the most aggressive pilot in 242 Squadron. If anyone would test the restrictor to failure, it would be Bader. Shilling installed the restrictor herself. Bader watched. He asked technical questions. Fuel flow rate, maximum G tolerance, failure modes. Shilling explained the mathematics. The restrictor would prevent flooding, but would not eliminate the brief stutter. During extreme -G, Bader understood. A brief stutter was survivable. Total engine failure was not. Bader took off at 11:23, climbed to 15,000 feet, rolled inverted, pushed the stick forward hard. -4 G-forces, more than any combat maneuver would require. The Merlin stuttered for a quarter second, then held power. Bader held the -G for 3 seconds. The engine ran smoothly. He rolled upright, dove to 400 miles per h, pulled into a 7G climbing turn, rolled inverted again, pushed negative. The engine stuttered, held. Bader repeated the maneuver 11 times. Different altitudes, different speeds, different G loadings. The restrictor worked every time. He landed at 12:07, taxied to the hangar, shut down the engine, climbed out of the cockpit, told Shilling her restrictor was brilliant, told her she had just saved every pilot in fighter command, told her Rolls-Royce could keep their fancy pressure carburetor. This was the solution they needed. Bader flew 47 more combat missions with that restrictor installed. Shot down 11 German aircraft. Never experienced engine failure during a diving attack. Shilling led a 3-person team on a tour of RAF fighter stations in January 1941. She traveled on her Norton M30 motorcycle, 490cc supercharged. The same motorcycle she had raced at Brooklands in 1934 at 106 miles per h. The installation procedure took 22 minutes per aircraft. Remove the fuel line between pump and carburetor. Insert the brass restrictor. Reconnect the line. Test for leaks. The restrictor weighed 2.3 grams. It cost 6pence to manufacture. It required no special tools to install. 3 machine shops in the Midlands produced 4,200 restrictors in 6 weeks. Total manufacturing cost, £1,050. Less than the cost of a single replacement Merlin engine. Distribution was handled through normal supply channels. The restrictors arrived at RAF stations mixed with routine maintenance supplies. Station engineering officers received classified installation instructions. Install immediately. Report completion. Do not discuss the modification. The secrecy was tactical. Better to let the Germans discover it gradually through combat losses. By March 1941, every Spitfire and Hurricane in fighter command had Shilling's restrictor installed. The tactical impact was immediate. Squadron 54, based at Hornchurch, reported the first combat results on the 29th of January 1941. Flight Lieutenant Colin Gray engaged 3 Bf-109s over the channel at 18,000 feet. Standard Messerschmitt tactic. The lead 109 dove away at -G. Gray followed. His Spitfire's engine stuttered for less than a quarter second, then maintained full power through the dive. Gray closed to 250 yards and fired a 3-second burst. The Messerschmitt exploded. First confirmed kill using a restrictor. Equipped Spitfire in a maneuver that would have caused engine failure 3 months earlier. Gray landed at Hornchurch at 14:37. The other pilots in his squadron surrounded his aircraft during shutdown. They had heard the radio traffic. They knew what had happened. Gray climbed out of the cockpit. His hands were shaking, not from fear, from adrenaline. From the realization that he had just executed a maneuver that should have killed him. He told his squadron mates the engine barely hesitated. Quarter-second stutter, then full power. He followed the 109 through a 4,000-foot vertical dive. Stayed on his tail the entire time. The German pilot never had a chance. 3 days earlier, that same maneuver would have left Gray gliding toward the channel with a dead engine. The restrictor had changed everything. Within 48 hours, every pilot in Squadron 54 had tested the modification. They rolled inverted, pushed negative. Their engines held power. The psychological impact was significant. For 16 months, RAF pilots had been trained to avoid -G maneuvers. Never push the nose down hard, never follow a diving enemy. The Merlin will fail, Those limitations were now gone. Pilots could fight the way they wanted to fight, aggressive, offensive. The Messerschmitt's dive away advantage was neutralized. The kill ratio shifted. Before the restrictor, RAF fighters lost 1.7 aircraft for every Luftwaffe fighter destroyed over the Channel. After installation, the ratio reversed to 0.84 British losses per German kill. The Messerschmitt's tactical advantage had evaporated. German pilots noticed the change immediately. Luftwaffe combat reports from February 1941 mentioned that British fighters were following them through negative G dives. Tactics that had worked for 16 months were suddenly failing. The Spitfires were not supposed to be able to do that. German intelligence attempted to determine what had changed. Captured Spitfires were examined. Engineers found the brass washer in the fuel line. They measured it, analyzed it, tested it. Their conclusion: a simple flow restrictor had eliminated the Merlin's primary weakness. The captured aircraft was Spitfire P-7350, forced down near Calais on the 2nd of March, 1941. Pilot bailed out safely. Returned to England. The aircraft was intact. Luftwaffe recovery teams transported it to Reclin testing facility. German engineers conducted a complete technical analysis. Every system, every component. They found the restrictor on the 9th of March. Small brass disc in the fuel line. They measured it with precision instruments 1-inch diameter, 0.03, 0-inch orifice. They removed it, weighed it, 2.3 grams. They calculated the fuel flow restriction, 99.2% of maximum flow permitted. They installed it in a captured Merlin engine, ran tests. The modification worked exactly as designed. The German engineers wrote a detailed report. The report concluded that the British had solved the Merlin's negative G problem with a component that cost essentially nothing to manufacture and could be installed by field mechanics in minutes. The report recommended that German intelligence determine how widely the modification had been deployed. If all British fighters had the restrictor, the Bf-109's tactical advantage was permanently lost. Luftwaffe reconnaissance photographed airfields throughout March 1941. Analysts examined maintenance areas, looking for evidence of widespread modification programs. They found none. The restrictor installation left no visible external changes. No new equipment, no modified cowlings. German intelligence concluded the modification was probably limited to frontline squadrons, possibly only elite units. They were wrong. Every Merlin-powered fighter and fighter command had the restrictor by late March. The Germans did not know this. They continued to use negative G dive, away tactics through April and May. British pilots continued to follow them through the dives. German losses increased. By June 1941, Luftwaffe tactical guidance changed. Bf-109 pilots were ordered to avoid negative G evasion against Spitfires and Hurricanes. The dive, away advantage was officially acknowledged as neutralized. The restrictor was not perfect. It did not allow sustained inverted flight. Negative G maneuvers longer than 4 seconds would still cause power loss. But combat maneuvers were measured in fractions of seconds. A pilot needed 2 seconds to roll inverted and push into a dive. The restrictor provided that capability. That was enough. The permanent solution arrived in 1943. Bendix, Stromberg pressure carburetors, fuel injection, style delivery without the complexity of true injection systems. The new carburetors eliminated all G-force fuel delivery problems. But they arrived 28 months after Shilling's restrictor, 28 months during which RAF pilots fought the Battle of Britain, defended Malta, flew convoy protection over the Atlantic, and escorted bombers deep into occupied Europe. One of those pilots was Flight Lieutenant James Johnson. 19 years old when the war started, joined the RAF in 1940 Spitfire pilot with Liu Yaoliu Squadron. On August 1940, Johnson was escorting bombers over northern France. Altitude 1,010 feet. 4 Fokker Wolf E-by-Joshires attacked from above. Johnson broke left. The lead FW Fu E-by-Josher followed. Johnson reversed hard, rolled inverted, pushed into a vertical dive. Negative G. His Merlin stuttered for a fraction of a second, then held power. The FW Fu E-by-Josher pilot expected the Spitfire's engine to fail. He committed to his dive, planned to follow Johnson down and finish him at lower altitude. Johnson's engine did not fail. He maintained the dive to about 10 feet, then pulled into a climbing reversal. The FW Fu E-by-Josher overshot. Johnson fired a 4-second burst at Yalbadian yards. The Fokker Wolf exploded. Johnson survived the war, flew Wu combat missions, shot down senseless enemy aircraft, became the highest scoring RAF ace who survived the war. He retired as Air Vice Marshal in Jobai. He kept a brass restrictor on his desk for 6 years. The restrictor from his first Spitfire, serial number N-Fei Joshaba. He told people it was the most important piece of equipment he ever flew with. More important than his guns, more important than his radio, more important than his parachute. Because without it, he would have died on August Shuwu Th. Jobai Sicherar over France when he was 8 years old. The restrictor gave him 6 or years of life. Fighter Command estimated that Shilling's restrictor prevented approximately 11 aircraft losses between January and September. Each prevented loss saved 1 pilot's life and preserved 1 aircraft worth £10 of production cost. Lil aircraft, TDRNR lion pounds in hardware. Lil pilots who survived missions they would have lost without the restrictor. Some of those pilots shot down Wu enemy aircraft each. Some shot down Shi. Some became squadron leaders and trained hundreds of other pilots. The tactical and strategic value of Shilling's 6-pence brass washer was incalculable. The Lil Bias Abd pilots included men who would shape post-War aviation. Test pilot Neville Duke flew restrictor equipped Spitfires over Italy in Jobai. Survived Arshalo negative G combat engagements. After the war, Duke set the world air speed record at Sibai Arshatsi less per hour in Jobai Wushisen. Squadron leader Robert Stanford Tuck shot down Arshajil enemy aircraft flying restrictor, equipped Hurricanes and Spitfires. Captured in Jobai Sicherar, escaped. Rejoined the RAF post, war career as a test pilot and aviation consultant. Wing Commander Johnny Johnson, no relation to James Johnson, Senshaba confirmed kills. All in restrictor equipped aircraft, became the RAF's top scoring fighter pilot of the war. Post-war career included command positions and aviation writing that influenced fighter tactics for decades. These men lived because Shilling's restrictor allowed them to fight without mechanical handicap. Their post-war contributions to aviation engineering, pilot training, and tactical development were directly enabled by surviving the war. The restrictor did not just save lives in Jobai. It saved the knowledge and experience those pilots would contribute for the next wusha years. Beatrice Shilling received the Order of the British Empire in Jobai. The citation read, "For services to aviation." It did not mention the restrictor. It did not mention the carburetor modification that neutralized the Luftwaffe's dive away advantage. Official roles Royce documentation attributed the Merlin's improved negative G performance to engineering analysis and carburetor development programs. Shilling's name did not appear in the technical reports. The brass washer became known among RAF pilots as Miss Shilling's orifice. The nickname was coined by Sir Stanley Hooker, Rolls Royce's chief engineer for supercharger development. It was meant as a compliment, a recognition that sometimes the best engineering solutions are the simplest ones. A brass disc with a precisely calculated hole, Ardern grams, sixpence worth of brass. Arsharfindon used to install, and it changed how air combat worked over Europe for Arshabami ons. Shilling continued working at the Royal Aircraft Establishment until Iten She worked on rocket propulsion systems. She analyzed wet runway braking performance. She helped design the British Olympic bobsled team sled. She continued racing motorcycles and sports cars well into her 60s. She married George Naylor, an Iten fellow engineer, RAF bomber pilot during the war. They built race cars together in their home workshop. Modified Austin Jan Healy Sprites. Lagonda Rapiers raced at Goodwood Circuit, won several races, placed third multiple times. In Iten American racing driver Dan Gurney asked Shilling to solve overheating problems with his Eagle MKE Formula E car. She was Wushaba years old. She analyzed the cooling system, redesigned the radiator ducting. The car ran cooler. Gurney finished fourth in the championship that year. Shilling retired at age Lilshire with 17 years of service. She never spoke publicly about the restrictor during her career. When asked about her war work, she said she did carburetor research. Nothing special, just engineering. Other people did more important things. She kept one restrictor, the prototype she machined in November She stored it in a drawer in her workshop. Visitors who saw it asked what it was. She told them it was a fuel line component. Most people did not ask follow-up questions. A few engineers recognized what it was. They knew the story. They understood what that small brass disc represented. Those conversations stayed private. She died on November Iten Joshi. She was Basha years old. Her obituary in the Times mentioned her work on aircraft engines during the war. It did not mention the restrictor. Most people who read the obituary never knew that the woman who just died had saved Leoninian pilots' lives with a piece of brass the size of a shirt button. Her husband George died in Iten Joshaba. Their workshop was sold. New owners found the prototype restrictor in a drawer. They did not know what it was. They threw it away. The actual first restrictor that neutralized the Bf-109's tactical advantage no longer exists. Lost to history because it looked like scrap metal. The restrictor itself is preserved at the RAF Museum in Hendon. Display case B small brass washer, 1 inch diameter. Inch center hole. No placard, no explanation. Just a brass disc that most visitors walk past without noticing. The Spitfire next to it has chassis kill markings painted on the fuselage. The Hurricane across the hall has Shii. Both aircraft have Shilling's restrictor installed in their fuel lines. Neither display mentions it. That is how innovation actually happens in war. Not through committees or procurement programs, not through month engineering development cycles, through engineers who see problems that need solving immediately, who build prototypes in home workshops, who machine brass washers to 5/10 and thousandths of an inch tolerance on personal lathes, who ride motorcycles from airfield to airfield installing unauthorized modifications that void engine warranties and save pilots' lives. The Messerschmitt Bf-109 was a superior fighter aircraft in many ways. Fuel injection, better dive performance, excellent rate of roll. But it could not overcome Ardern gram brass washer that cost sixpence and took Arsharfindon to install. That is the difference between engineering elegance and engineering urgency. Rolls, Jan Roy spent months developing a perfect solution. Beatrice Shilling spent 6 days developing a solution that worked. Leoninian pilots came home because she chose urgency over perfection. That is the only number that mattered.